Hey folks, this video is for anyone who's fully remote, who did not get to participate in the Newton's Third Law Lab. Sorry for the tilted screen, but so let me see if I can do this. That's worse. That's better. So this is just a visual guide to the lab. You're gonna go to the Newton's Third Law Lab and complete this kind of along with me. Um, and so just to kind of give you an indication of what this lab is all about, I have in front of you, you see two dynamics carts, and each one has a force probe on it that's got like a bumper to it. And so if anything pushes on that bumper, it will register a force um, on the screen there. So if I like press on this one, you can see that this is force 2, and then I release, it goes back to 0. And then if I press on this one, uh, that one's force 1. So, and the position one down there is not really going to do anything. So that's the sensors. And so basically what's going to happen is I'm going to arrange 5 different scenarios where the carts will hit one another and bounce off. And they're going to make force graphs over time. So we haven't looked at those yet, but it's no big deal. It's just registering how big the forces are as things collide. So what I need you to do is make a prediction. Now, since you're working at home with this video, you're not going to do a lot of the first page. You're only going to do like the first half. So it says, look for the part that says individual prediction and make a check next to your prediction. So basically what's going to happen is the two carts that you can see have about equal masses. And I'm going to push them toward one another so that they collide and then bounce off one another. So they have about equal and opposite velocities as they come together and about equal masses. And so your prediction is going to be to compare the forces. So read the choices and make your selection. I would pause the video now and do that. When you're done, you're going to go skip to the next page. So ignore the bottom half where it says small group dialogue, since you're not going to be talking in a group, and go to the part where it says results of investigation. Now, what you should have already on the front page is like a drawing of what you think the graph is going to look like for that collision. So it can kind of be like anything you want. And now I'm going to make the graph and we'll talk about it. So I'm going to start data collection with them separated like this, and then I'm going to push them together and stop data collection. I'm probably going to have to like catch things as I go. And so we'll see how this happens. Here we are. Well, there we go. And that's it. And so this graph, I'm going to have to edit this a little bit so you can see really the true shape of this graph. And there you go. So let me do a little bit better. Okay. And so what you're going to do is in your handout where it says graphic representation, this is on the second page. Kind of put it up here so you can see. Actually, even better, I'll put it up here so you can see. Kind of right where my mouse is, you're going to draw these graphs in different colors. And the other thing you're going to do is you're going to draw a force diagram. Now it says red and blue. Let me go grab a red and a blue pen. Use a red arrow to indicate F12 and a blue arrow to indicate F21. So there's something to get used to here. And fortunately, the Logger Pro software makes it easy. Car 1 is going to be on the left-hand side. And when you draw F12, that stands for the force of car 1 on car 2. So car 2 is going to get pushed to the right. F21 is the force of car 2 on car 1. And so you're going to draw a blue arrow to the left. So the force diagrams should look like this. Car 1 pushes car 2 to the right. Car 2 pushes car 1 to the left. So just so that you can say like which way they were pointed. And so the last part is the graph. You draw the graph to the best of your ability. It's just a spike. And what you want to notice is that those spikes are like perfectly symmetrical. So, the graph starts to go away from 0 at the same time. The spikes are happening at the same moment, and then it goes back down to 0. And so the forces have the same size and they have the same duration. One of them is in the opposite direction as the other one. So now you're going to complete these like claims for 1, 2, and 3. So make a written claim comparing the size of the forces and then the evidence. And so the evidence is going to be like point to the graph and talk about how the evidence supports what you say. Number 2, make a written claim comparing the direction of the force. So notice that one of the graphs in the positive and one of the graphs in the negative, and that's going to matter. So there's that. So if you have questions, email me, and then when you're done with those 2 pages, you're going to move on to the next page, and the next page has 4 different scenarios. And so I'm going to go through them pretty quickly. So find situation 2, you can always pause. Find situation 2. In situation 2, car 1, they both have the same mass again, but car 1 is moving to the right while car 2 is initially stationary. And so I'm going to have cart 2 sit here so you can see it, and I'm going to push cart 1 into it when I start data collection. And I am going to go back down to 0, and I'm going to go back up to 10 just in case. Okay, here we go. And there it is. So there's the spike. I think I'm probably just going to have that, and I'm going to try and do it in the 2 to 4 second range. And so there, I'm going to go to 15. Okay, so there's your spikes. And so that's situation 2 when cart 2 is stationary. And so you can, like, again, make a written claim, draw your graphs. So, you know, kind of how this works, or I should have explained this earlier. There's like 2 graphs next to one another. You have a prediction and an actual. And so before I like start data collection, you want to do the prediction part. And then after the graph is made, you want to draw the actual part. And so you'll have like a prediction and an actual. And I think after the next one, your graphs will pretty much match mine. So that's situation 2. Situation 3 is interesting because it says basically car 1 is chasing and colliding with car 2. So this one's hard to like have happen. But what I'm going to do is I'm going to start everything over here. I'm going to push cart 2, and then I'm going to push cart 1 harder than that so that cart 1 catches up with the other cart. Let's see if I can actually do that. There we go. And of course, that didn't like happen in the time frame, so let's see where it was, and there we go. So there's your next graph. I guess I'll put that so you can see it nicely between 1 and 2 seconds. And so there is your there's your graph. All right. Okay. So next up is that's situation 3. Situation 4 is on the back. So again, I keep forgetting, but please make your predictions before I do data collection. Situation 4, bus and car of unequal mass collide. The bus and the car are moving toward each other with equal speeds. So I have to make the mass of cart 1 bigger. I'm going to pause and do that and then tell you about how I did that. Okay, so all that happened for the bus is I added this brick, and the brick is like 250 grams, and it's like bolted to the cart. So now we have that. The bus and car of unequal mass are moving toward one another with equal speeds, and so this is number 4. So make your prediction about the force graphs, and this is the same setup as the first one. So I'm going to push them toward one another. There we go. That one actually popped up in this window here, and so there's your graph. So that's situation 4. And then situation 5 is the same masses. So again, if you need to pause. Situation 5 is they're both, it's the bus and the car again, but this time the bus just like collides with the stationary car. And so this will be our 5th and final station. Okay, and so I missed the window there. I think it happened afterwards. So I'll put it up there. There we go. Okay, so I'll have that go to 4. And so there's your fifth and final station. So when you are done, you should have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You should have drawn 10 of the 11 graphs on this assignment. So if you missed anything, you can go back. You should have drawn force diagrams on the front page and the second page. You have a lot of open response answers on the second page, and then basically everything of the second sheet of paper should be completed. And that's it. So if you have questions, send me a message.